Okay, folks, I think we're going to go ahead and get started. I'm going to go ahead and launch my PowerPoint. Can everybody see the PowerPoint? How about a rounding yes for everybody? Yeah, it'll be slow because I set up the resolution a little bit higher, but I think once we get past the videos, we'll kick in. So welcome everybody to the quick trip around Autodesk BIM Solutions. My name is Eugene O'Day, and I will be your presenter today. A quick thing about the PPI group here. If you haven't heard of PPI, we are the longest standing Autodesk reseller in the Northwest. A couple of my favorites is, been around since 94, 29 years of selling the software and supporting our community. Plus, we're also the only company in the Northwest that understands and provides field to finish solutions in the Pacific Northwest, meaning from the dirt all the way to the building and then the demolition of the building. Here's just a little quick trip around who we are. Here's our team at a glance, and there's a pretty picture that Don said I could use. So with that, here's our agenda. I'm going to give you just a brief refresher of BIM and what BIM actually is. And then we're going to go into working with the different products, all three Revit products. And then we're going to get into a little bit of Navisworks, talk about how it reviews and coordinates between your models, and then introduction to point clouding and what point clouds are and how point clouds work with inside of Revit. And then at the very end, we'll have a little open discussion. So with that, I'm going to go and start off with BIM. Now, after this particular slide, I'm going to mute everybody so you can see what's going on. And a couple other things here with my PowerPoint. I had some videos built in, and only half of them work, so I'm going to toggle between the videos and the PowerPoint. So I'm going to go back and forth between that. So before I mute everybody, and Teo can answer this question, neither can Ty, what is BIM? Somebody. Exactly. Now, the reason why I always ask the question is because some people think or hear that it's management and not modeling. And the whole idea behind the management side of things is you have to have the model before you can manage anything. You can't manage lines, arcs, and circles. You can't really manage an extrusion, but you can manage walls, doors, and windows, and ducts, columns, things to that nature. So a couple little tidbits on BIM. First is it's a coined phrase by Autodesk. And then the second thing is, if you're not familiar, BIM is not a product. BIM is a process. So even though Revit is a BIM tool, it's not the all-inclusive tool for BIM. It is one of the tools that gets you down there. So with that, I'm going to go ahead and just mute everybody, and then at the end of the presentation, I'm going to unmute so we can answer questions, okay? Well, apparently I didn't mute everybody. Can you guys hear me? Can you guys hear me? Okay. So I muted myself and not you guys. Proceed with the mute. I'm going to go ahead and just keep it like this because apparently I don't have the right keypad to mute you guys. So I'm going to go ahead and start. So B for building is basically what the architect envisions for the client. Information is the drawings, the schedules, the specifications for the coordinated. And there's two I's for that. Really, it's upstream, downstream. So this information we're sharing throughout the model. And of course, M is the model, which is the digital representation of the actual building that you're trying to design. So what is the purpose and what is the goal of BIM? The goal of BIM is basically take all of these people, put information into the model and extract information out of the model. That's really the goal of what BIM is. The purpose of BIM is lifecycle management. So the whole idea is that you start from where the ground is, demo the ground, grade the ground, get it ready for the building, put the building on, demo the building, and go forward. So the whole idea behind this is lifecycle management. So why do we want to go to BIM? What's wrong with our current discipline or our current way of thinking? Well, think about this word collaboration. I always like to start off with this. So when we look at collaboration, do you guys kind of agree that when you hear this word, this is kind of what you think of as a definition of collaboration? Somebody can say yes or no. Okay, but what about in our field? What about this? This seems to be more what's happening instead. Exactly. So I want you to think about the industry in general, what's happening in the world today. Think about cell phones and think about phone technology when your grandparents had a phone versus when your parents had a phone versus you and then the kids. Think about the cell phone technology that has just increased in the last couple of years and all the functionality that we can have with phones. Unfortunately, on our industry, we have gone downhill as far as productivity goes with all that stuff. So the whole idea behind this is thinking about a better way to get things done. So you might have seen this particular slide before. So the ability to impact cost from a contractor standpoint can happen, at the beginning of the stage, but they usually don't get it till the CA side. And what's going to happen is, of course, the cost at the CI side is going to cost more. So there's kind of a sweet spot in our traditional CAD that we do most of our work over in the CD stage of things. Is that would you guys agree with all that? Okay. But with a BIM solution, what we're going to do is we're going to do most of that stuff up front in the schematic design development, and we're going to reap that benefit over in the CD side of stages. And I'm going to kind of show you a little bit of that today. Another report that they did, the National Institute of Standards, was think about how we go about things. So we plan things, then we take that planning, when we have so much of our design, we build upon that, and then we take it over to construction. They take so much of that and they build upon that. Then we take it over to operations. They take so much of that, build upon that. And this particular way of doing things, this cost is in the 2007-2008, $16 billion worth of waste in the US alone. Now BIM doesn't solve all of that, but it helps a lot of that. And here's one of the, kind of an example that I'm talking about. Now this particular slide kind of goes into what I'm looking at, but I was out in the field years back and they were building a white room, and they were building this out on the construction site, kind of like this picture kind of shows. And then once they got done doing that, they tore all the information down and then went into the building and actually built it. That's that $16 billion worth of waste that's happening right now. They need to verify that this is going to work before they actually go build it. No, this was years and years ago that I was there. So looking at a set of documents, depending upon who did it, I'm not going to say you guys did this, let's say it's my documents, the building may end up looking like this. So that's why we get a lot of RFIs. So think about in traditional CAD, can you find and see that 3D pipe or that pipe running into that duct? Not very easily. But in a BIM solution, you can actually see that running into it. So that's kind of the idea what we're heading for. So what technologies are out there that do BIM? There we go. So there's a couple different CAD files, things going on out there. So you have what we call flat files, and a flat file will be something like Word, PowerPoint, AutoCAD, things of that nature. Excel is thrown in there as well because Excel is still somewhat flat, but you can link things together in Excel, but you can also break the links, if you will. Whereas in a database scenario, you can't really break those links. Those links are there and that's what it is. So the different types of technology out there that can do BIM: CAD, Object CAD, and parametric building modeling. Now, CAD, think of that as AutoCAD. And you can take AutoCAD and build upon that and get some level of BIM. And a great example is like the sheet set manager and things of that nature. You can do that. Now with Object CAD, that would be something like ADT or AutoCAD for Architecture or AutoCAD MEP, things to that nature, that's an object CAD where it has some bit of intelligence behind it. Civil 3D is actually kind of falls in between object CAD and parametric building model, where they have some parametrics in that. The problem with the CAD products is that you have this lovely command called explode, and as soon as you explode something, you lose that intelligence. And that's the whole idea. Now when it comes to parametric building modelers, there is no explode command. A door is a door, a wall is a wall, and that's what it is. So just a quick look at some of the reasons about Revit. And I'm gonna, there we go. So this particular one, not necessarily about the design and how the building looks, but it's what they did with Revit within that. So you're looking on the one on the right and the one on the left, basically different entries in the same building. Now in CAD, these are different design options, and we would build those up in separate files typically. And let's say that the client has 3 choices, and they choose option A. And then 3 weeks later they come back and say, I want option B. Well, we got to take option B and build it back up to where option A was. In Revit, it's literally 4 clicks of the button to go from one to the other. And I'll kind of show you that today. The other piece of this building was the city was concerned with 2 things. They were concerned they could see the mechanical on the roof, and they were concerned that the building would shade the pool across over in the park. So with a quick snapshot in Revit, you don't have to worry about that. So think about in AutoCAD, how are you going to determine with lines, arcs, and circles that that mechanical is not being shown? With Revit, you just pick a point, another point, and you got your camera. How are you going to determine in CAD that the building does not shade the pool at a certain time of day? In Revit, it's just a sun study. So with that, let's look at some Revit technology. So I'll quickly get through a couple slides here. There we go. So think about, again, starting with a building. So when you have that model, you can do a lot of different things with that. You can do sustainability analysis, you can do conceptual design, some fabrication. We can coordinate with other functionalities or other disciplines. So I'm going to go ahead and just escape this out. I'm going to pop over to my videos, and I'm going to run just basic Revit. So what I want to talk about here is, what is Revit? And this really kind of manages all products here. So we're talking basically all Revits, but I'm using Revit architecture to kind of show what's going on. Okay, so first off, when you pick a door, or when you want to edit a door or move a door in AutoCAD, typically the stretch command is what you want to do, because you want to basically grab this opening because you have lines that are representing the wall. In a parametric building modeler, it's relationship driven. One of those relationships is all about the dimensions. So when I grab on that door, I'm just going to pick it, and I'm going to change the dimension to be 6 feet, and it automatically moves it to 6 feet with the opening as well. Now if I want to create relationships between things, there's a couple tools that do that. So what I just did was create a relationship between the 2 doors. I pick one door, both doors are going to move. Think about how long it takes you to draw building sections. So all I'm going to do is grab the section tool and zoom out and throw in the section. Yeah, I'm watching the other one there. I have 2 machines going on. Okay, so there's our building section. And looking at this building section here, what I did was just kind of switch it over to different graphics so we can see it. Now if I grab the section and I flip it, you should see that the section view automatically flipped as well. If I pick the door over in the section view, you should see the door kind of highlight over there. So I'm going to do a zoom up onto that door, and when I pick the door, it moves. It moves every place. If I delete the door, it deletes it every place as well. So think about this as, a door is one object. Unlike in traditional CAD, what's going to happen is you delete that door, then you got to remember to go to all the other drawings to open up that door to delete it. So in traditional CAD, we don't have to worry about, or Revit, we don't have to worry about that. So I'm going to go ahead and zoom up on the corner here. Think about how you go off and draft. If I want to extend this wall over, I'm going to use the extend command, the trim command to clean up all these things. In Revit, I'm just picking and I'm just dragging it over, and what it's going to do is automatically it's going to update that corner. If I want to place a door in, typically it's a block that we insert, and then we do some trimming to get rid of the opening. Here, Revit's going to insert the door. It's going to put in the door tag if you wish, and cut out the information that needs to happen. Now, let's say that I want to match these two doors up. So if you look at the double door, that is a double flush door, 72 by 82 inch door, and I really want the single door to be the same. So if you look over in the schedule side of things, there's 14 of those doors. So what I'm going to use is a typical command that we use in a CAD called match properties. So I'm just going to match that over, and you notice that the door now changed from 14 to 15. So that really is one item that we don't have to, and we don't have to worry about any other place that it is. Another great example is like rooms or schedules in a sense. So when we go off and we do the schedule and we put a little room in, what's going to happen is when we place the room, automatically puts in the square footage, does all the good stuff for us, and then it fills in the schedule. Now we can modify this any two places. We can do it in schedule, we can do it in the tag. So if I change the schedule, notice the tag updates. If I change the tag, notice that the schedule will update. So again, wherever you feel comfortable making these changes, that's where things are going to happen. So this last piece, what I'm going to do is throw in a title block. So it's all about coordination. So think about a lot of the times that we spend on verifying call out information. So a lot of that time we spend in CD is verifying what we've drawn is in the right spot, all that kind of good stuff. So looking in Revit, looking at this call out, that call out basically tells me that it's not on a sheet of paper. Guaranteed not on a sheet of paper. In traditional CAD, that's not necessarily the truth. But in Revit it is. So when I place that drawing in, or place that section in, it automatically fills in the call out. And that's always going to be right. Guaranteed. Now I don't like really the number, so what I'm going to do is go and change that number to, let's say, A501. Now as soon as I do that, I got a little warning. That warning kind of went pretty quickly here. I got a warning that basically told me that I cannot have a 501 because 501 already exists. So I can't have multiple sheet numbers to work on that. Now the other idea behind this is if the sheet exists, I can't have it, but if it doesn't exist, I can. And you notice that when I change it to 500, the bubble automatically updated as well. So that's a kind of a quick trip around some basics. Let's do a design option. I kind of told you about design options earlier. Now what a design option is again multiple ways at looking at your building or looking at your design. So what I have here is on the second floor, I have this area here that I want to flesh out a little bit more. So I'm going to go ahead and mute you guys. I got a number here. All right. Okay, so what I have here is a design option. What I'm going to do is switch over to the design option, show you a little dimensioning option here as well. I'm going to go ahead and throw in a dimension. I'm going to do a center line of core. I'm going to go ahead and do entire wall. I'm going to do wall intersections. So as soon as I pick on that, I automatically did it, and then I put the equal symbol on there. And what the equal symbol allows me to do, as you see I'm adjusting it, it allows me to go off and have them all equal. I'm going to go ahead and switch over to option number 3. Option number 3 is a blank screen basically. Everything gray is part of the model. Anything not gray, or in this case dark, is going to be part of my actual design option. So what I'm doing here is just popping over to the wall command. I'm choosing the type of wall I want, which is going to be a basic generic wall, 4 inches. I'm going to have it unconnected right here. And then I'm going to go ahead and say center line of wall. Then I'm going to choose where I want the wall to be, and then how long I want the wall to be. And I'm going to go ahead and switch it over to, let's say, an arc. Make the contractors upset. Make the budget go up a little bit. And you notice that when I go down to the arc below, there's tangency. So that's part of that relationship again. All right. Now let's go put in a couple walls up here on this side for some desks. Now when you look at this, you have the ability to choose where your wall connections are going to be. And I can flip that around if I got the information wrong. And we'll go ahead and put in the desk. And let's array that desk. So with the array command, basically choosing how many I want, and then I'm going to go from grid to grid, and automatically goes off and throws them in. So you can see what I just did. They were switched back to what we call the primary view. Now what I'm going to show you here is all the different looks and feels of the options. So there's that design option in a 3D view. So sometimes, our clients can't necessarily see what we're talking about in 2D, but we can throw a camera in really quickly and show them that. So what I have here is 3 views that are camera views. I already created that one. And then if I go down to my sheet, because I basically need to put this on a sheet for the client, when I look down at my sheet, we're going to see that we have all of them except for that one option I just created as a floor plan. So what I'm going to do now is go ahead and create that floor plan view to put on a sheet. So I'm just going to grab an existing one and basically duplicate that view. Now once I've duplicated it, what's happening is that you're seeing the design option 2, but I really want to show design option 3. So that's that quick trip around. All I want to do is rename it so I have the right view. And I'm going to go into what we call visibility graph. Just kind of think of that as like your layered dialog box. But within that I can say what design option I want to see in a particular view. So you can see right away that it kind of switched over to that one, and now all I need to do is just kind of drag and drop it onto the sheet. Now when I drag it up onto the sheet, it actually has lining up tools to allow me to line up different ways. I'm going to go center and edge, and it lined them up for me. Now here's that piece of the pie there. So the client 3 weeks later says, oh, Eugene, I kind of want option number 3. So what I can do is go into the design option box. You can see right now that option number 1 is called primary. What I want to do is make option number 3 primary. And as soon as I do that, what's going to happen is I'm going to get a warning saying, hey, I'm going to delete some stuff in your model. And I'm doing that because you have different design options. So option number 1 had doors. Option number 2 and number 3 didn't have doors. So what it's basically telling me is that the schedule is updating based upon that information. And there's that 4 clicks of the button I was talking about. Now, the last thing I want to do just in general Revit is talk about detailing, because a lot of people say, well, okay, you're modeling, what are you doing with that and how do you do details? So I'm going to show you just a quick trip around how we do detailing, and not necessarily detailing, but details that are already pre-done. So what I have is already drawn some details and I want to bring them in. So what I'm going to do is, you can have detail libraries just like you do in CAD. I'm going to go and import those in, basically what we call as a link in. Grab a view. I'm going to grab an existing Revit project that has my interior details. It'll take a minute to bring in. So what you're going to see is all the information that I can actually bring in through. So you can see that I can bring in renders, I can bring in schedules, and I can bring in what we call drafting views. What I'm going to do is bring in the sheet that has most of those on there. And when I bring that sheet in, what it's going to tell me is, oh, by the way, you had some things happen here. And what that really means is, it's kind of like a layer in AutoCAD. If you have a layer called wall in the current drawing, you have another one you bring in, it's going to look like the one that's in your current drawing. And that's what it was telling me about all those things. We're going to use your current standard project. So now what I look at when I look at my what we call a project browser over on the left hand side is all the stuff that it brought in. So you can see that it brought in a section called Drafting Views Interior. And then all of those details. So I can click on any detail and it'll pop me in and show me that particular detail that I have. And it also brought in the sheet. So when I go down to the sheets, you can see that that actually brought the sheet in as well. All right. Okay. Revit MEP. It's really taking a bit there to get their graphics, isn't it? All right. So just think of this as the same functionality as we had before there. That we have a model, and when we have a model, we can do things with it. So we can coordinate with the other disciplines, we can create shop and fab drawings, and we can do some analysis to that. So let's do some conduit layout. Okay, so first thing I want to do is adjust where the conduit's going to go into my box. And I'm going to go and choose an appropriate conduit. So you can look on your screen here and you can see that there's a couple different options to choose from. We have conduit with fittings and conduit without fittings. And I'm going to choose what diameter I want for my conduit. And then I'm going to just connect it. And I'm going to say, okay, let's go and make it 9 feet. And then start drawing. And you can see that in the 3D views, things are happening. I can go and adjust it down to 9 inches for an offset. It drops it down. And then I can go ahead and adjust the other side where it's going to connect into. All right. In addition to that, let's do some cable trays. Same type of thing. What type of cable tray do you want? Do you want to have cable trays with fittings? Do you want to have cable trays without fittings? I'm going to go and use the ladder cable. And it actually works the same way as what we're doing with the conduit. So what's the width going to be? What is our height going to be? Where are we going to start it? What's the offset? So think about how would you draw this in CAD. Now there's some unique things about our parts here and our pieces here. So what's going to happen as soon as I get done with drawing this one piece, I decide that I really don't want that elbow, maybe I want a T. All I have to do is pick the control point, changes it over to a T, and then I can connect to it. So I'm basically connecting to that particular tray. And again, I do it on the other side here, and then just connect to it. Now all of these are parametric, which means that if I grab one and move it, the connectors are going to go and extend and move with it. Let's add some conduit to the tray. So I'll go and pick my conduit button and connect right onto it and pop her in. Excellent. All right, something new here for those people that have seen Revit MEP before. This is slope piping from Autodesk 2012.
Slope piping values of Revit MEP 2012 support enhanced productivity for piping design. You can easily create pipe slope values and transfer them from project to project for design efficiency. You can create the pipe slope values in the mechanical settings under the slope category. You also now have more control when creating slope piping layouts. The new icons allow you to easily slope pipe up, down, or use no slope at all. When drawing a slope pipe with ignore slope to connect enabled, snapping to a slope pipe with a different elevation is easier than ever before. When the tooltip is on, you can now see the actual elevation as you move your cursor in the desired direction. This will show you the elevation of the pipe at that particular point that your cursor is located. As well, you can easily connect to a vertical riser without worrying about where the pipe will snap to. It's intelligent, and it understands that you want to maintain the slope and simply connect where it intersects with all the necessary fittings. So when connecting plumbing fixtures to a slope pipe, you'll want to use the ignore slope to connect to them to ensure that you connect to the slope pipe correctly. It'll place the proper fitting based on the routing preferences. Now, as you continue to add fixtures to the slope pipe, each fixture will be connected to the slope pipe at the correct elevation and location of the fixture along the slope pipe. Now, when drawing a slope pipe with ignore slope to connect enabled and snapping to a slope piping with a different elevation, the values for the current offset and slope shown in the slope tooltip are the actual elevation and slope. You should also keep in mind that the current offset and slope at the snapping point are calculated based on the center line of the pipe, not the top or bottom. So,
all right. So that was a brief look at Revit MEP. There we go. I think this works a little better. Let's do Revit structure next. A couple of little things about Revit structure I want to show you. So beam systems. So think about how things get together and think about parametrics. In AutoCAD we can do the array command and things of that nature, but they're not necessarily intelligent. So what I'm going to do here is go ahead and put in a beam system, and this actually works in Revit structure and Revit architecture. So Revit architecture does have some of this functionality as well. So what I'm going to do is just put in a beam system here, and then I'm going to edit that system because I didn't like the direction that it's going. So we have a way of setting up the different directions, so I can pick anything I want. It goes off and sets the direction up. So again, when we create a system, what we're looking at is how many do we have, where do we want to place them. So you can see right here we have beam systems, things of that nature. There we go. It's going a little too quick for me. Okay, so what I just did is change the direction by drawing a line to say where I want my beams to go. Now I'm looking at this and I have flanges 21 by 73 and then a fixed number of 3. I'm going to go and change that for that particular one. I'm going to go and say let's do a maximum spacing of 3 feet, and you can see what's going to happen in the systems. Now the other thing that I didn't do on purpose was I didn't tag anything. So when you want to tag something in all of the Revit products, there's a couple of ways to do that. This one is called tag all not tagged. So it's going to go throughout my entire view and look for tags that have not been tagged. And I'm going to go and use the standard structural framing tag. And you can see right away that all of those automatically updated. Now the tags are intelligent in the fact that they report back information about a particular part. So this is a W21 by 73, and if I change that to be something different, the tag is automatically going to update for me. So that's kind of the building that we're looking at. And I want to put in a truss here. So I'm going to go and zoom up onto that little area right here. I'm going to throw in a truss. Now what I'm doing right here is clicking on the actual elevation. And what's important to note here is that the elevation doesn't have to show you everything about that particular area. You can say how much information you want to see or not want to see. In this case, I just want to see what's going on with that particular area of the roof. And so what I'm going to do now is I'm going to go off and throw in a truss. Now when we look at trusses, there's a couple different ones we can grab. We have a whole bunch of libraries to choose from. I'm going to grab the How flat truss. I'm going to place it right there. Now as I look at this, I kind of want the span to be from 5 feet to 10 feet. So I'm going to go and change that to be a max of 10. And you can see that automatically adjusts to that. The other thing I kind of want to do here is I want to adjust it so it is going up to the actual roof itself. So all I need to do is attach this to the roof and automatically updates. I'm not liking the bottom chord, so I'm going to go edit this. So we always have the ability to go back and make some changes to it. So I'm going to grab this, make some changes to the bottom chord. Delete the existing one. There we go. Now I'm not really keen on the way that it cleaned up that bottom piece, and we have tools that allow us to go off and fix that. And I'm going to go pop into a 3D view that has just the information that I need to see. So again, all the views, we can say what we want to see, what we don't want to see. So I'm looking at this design and realize that I kind of want that bottom to be attached to the roof, or the floor in this case. There we go. All right, this last one in structure is a 2012 functionality that's new. What this allows me to do is create what we call assemblies. This again works in either Revit architecture or Revit structure. And what an assembly is just a group of items that are common. So what I'm doing is grabbing the rebarb and the column and all the good stuff there, and I'm going to create an assembly of that. I'm going to call it what it is. I'm going to tell it that it's a structural column assembly, give it a name. And what's going to happen is down in the browser, we're actually going to find it's underneath at the very bottom of it called assemblies. And we can do a lot of things with that. But before I finish with that, what I want to do is talk about multiple assemblies. So I'm going to go ahead and grab this other one here. Looks really the same, but I'm not going to grab everything that I did before. So what I'm actually doing is using what we call a filter tool to filter out what I want. So I'm going to go and call it the structural columns, column number 2. So when I look down in the browser, again, we're going to see the 2 columns there. Now, any point in time that you want, you can edit any of these assemblies. So you can add information or remove information. And it looks like I grabbed or missed something, so I'm going to grab that one. I'm going to go and finish it. And it's going to come back and tell me, you already have one with that same name. It looks identical to it. So what's going to happen down in the browser is that it automatically updated that for me and said, no, these are the same ones. So if they're the same like parts, it's the same assembly. So you don't have multiple assemblies running around, kind of like a block in AutoCAD, if you will, but it's a little bit more intelligent than that. So what I'm going to do is go ahead and just finish up the rest of these to make them the same. Another key fact is, as we're waiting for this to finish up, is we're recording this, so the recording is going to be a little bit smoother for you as well, and we'll post that up on the web for you. All right, so what I just did, stepping back here just a minute, is created the assemblies and created the views. So you can look down here and you can see that there's a bunch of different views over in the browser. There's 3D views, there's detail views, there's schedules. And in addition, you can always go off and create more details, more sections if you need to. So there's a section I just created, and then I'm going to go and adjust it so we can see everything. Here's a parts list of that assembly. So it's going to show me all of the structural rebar, all the information about it, and then I can go and add more information to it. I can sort based upon different categories within inside Revit. I can sort by, let's say, the family and type. I can set up footers and headers. I can go off and do a calculation of the total of the assembly. How many of these things do I have? And then I can place these on a sheet. So now I have a shop drawing. All right, working together. So working in collaboratively together using all three Revits, and it could be that we have some AutoCAD flavors as well. I'm concentrating just on the Revit software right now. When I have a Revit architecture file, Revit structure file, how do they work together, or MEP versus Revit architecture, Revit structure. How do they work together, and how do we look at different things? So a couple different pieces to it. What we have is called coordination monitoring, and we have a functionality called copy monitor. And what copy monitor allows me to do is copy information from one file over to my current file and or monitor that. So a great example is grids. I want to monitor, make sure grids are moving or not moving, things to that nature. What we can do in Revit architecture, Revit structure, is levels, grids, columns, walls, and floors. These are things that we can copy and monitor. And in the Revit MEP flavor, there's a whole bunch of things that we can do in addition to. We can do air terminals, electrical equipment, a whole bunch of different lists of things that we can copy as well. So I kind of want to show you, this is an older video, same premise though. So, and I'm not going to argue with who's in charge of grids. I'm just going to let you guys battle that one out. So what we have here is Revit architecture, and Revit architecture has the grids and the levels, and what we're going to do is link in Revit structure all of that information. So what I'm basically doing is grabbing that architectural file, linking it in, and then what I'm going to do is do some copy monitoring on that. So now what you're going to see here is you got grids, you've got columns, and the columns that you're actually seeing are the round columns. Those are in the architectural, but they're what we call architectural columns, not structural columns. And so what's going to happen is we're going to do some copy monitor, and we're going to switch those over to structural columns. So what I'm going to do is grab my link, copy everything that I could possibly copy in this view. Grabs all the stuff, only highlights the stuff that it can copy. Now what copy actually does is makes a copy here in my model, and it's also monitoring that. So you can see right away that I had that circular column, which is an architectural column, but it actually replaced it with a structural column. So when we look at structure, there's a whole bunch of stuff that we would want to know about that necessarily the architect doesn't care. Now once we have that and we're working away, things may shift and things may change. So if I pop over here to the architectural file, I know this never happens. A grid gets moved, columns get deleted, things happen. Now think about this in traditional CAD. If I move that grid 6 inches, did you really know that that grid got moved 6 inches? And if so, you know, who takes charge and what's going on with that? And do we actually end up having that in the field? getting an RFI. So looking at this, I did a couple little changes to it, moved the column, changed the size. Think of this as CAD that something happened that we didn't know about. So when I go back over to my structure file, normally what would happen is we don't have to do this relinking stuff, but in the structure file, what you do is you just open up, or the MEP file, you just open up the file and I'll automatically will come up and say, hey, you got some problems. Here I'm just going to reload the file, and then I'm going to go and say, well, do I have any problems? So I'm going to go and do what they call a coordination review. So again, this is something that would pop up as soon as you reloaded your file. It comes up and says, you got some problems. First of all, you got a grid problem. You've got some positioning of the grids. You got some column issues. So when I look at this, what's going to happen is I can go narrow down and see what's going on with different pieces. So again, if that was a 6-inch instead of a large one, I can go off, okay, well, there's it is. Now right down here, there's a show option. So if you didn't have a particular view open, you can hit show to go look and see what's going on. So I'm going to go off and reset the grid. I'm going to go and change a couple things. So I deleted that column. I'm going to go ahead and say, yeah, delete that element. And then these all moved, and I'm going to go ahead and say, well, let's go ahead and move that. Let's postpone some. Let's do a bunch of different options here. So we have postpone, reject. So I'm going to reject this particular one. In other words, this one's not going to move. Now, anytime that you want to come back and look, because maybe you need to get a phone call and say what's going on with this grid, you can always come back to the coordination review side of things and say what happened with that. So you can put notes and comments and say, okay, now that I understand what's going on, we can either delete it or move it. All right, so on the construction side of things, we have a nice tool for BIM viewing and BIM coordination called Navisworks. There's a lot of things that they need to do. So looking over at the construction side of things, we've got structural, we've got architecture, we've got MEP, we've got all of the BIM solution tools for designing, including the 3D Studio Max design tool. And then over here they've got some other things that they need to worry about, like clash detection coordination, documentation, estimating, things like that. We're going to look at the clash detection coordination and the sequencing side of things. Now we can do clash detection inside of Revit. So I just want you to understand that this can happen in your current versions, and you can say, well, does the stair run into a column, or does my duct run into any structural columns or structural things? So we can do that inside of Revit. This is for more of a grandiose type of a situation where here I want to find out, do I have any superstructure running into any mechanical air supply? And what it's going to do is quickly run through and find 65 issues. And then it's going to allow you to zoom in and out and look for different functionality. So you can see that there's a clash. It pops over to the different ones. And we can look at how we want to manage and view this information. All right, so what we're going to do here is review this information for us. So what I want to do is say, let's go make some notes here and apply this so that the team can see what's going on here. So let's review this particular area. And we can create reports upon this as well. All right, this one we're going to actually work with the structural Revit, Revit MEP as well. So looking at this, you can see that the duct runs into the column, or excuse me, the structural member. And for whatever design reason, we decided to go up and down and over. So what we need to do is actually adjust that. So we have some functionality in the 12 versions called switchback. And what that allows me to do is switch back over. Switch back up here. Allow me to switch back over to the product if the product's something that we currently have loaded. So what he does is switch back over, and what we're going to do is adjust that in Revit MEP. So looking at the MEP side of things, here's that little duct, and actually we'll zoom to that area as well. I'm going to grab the offending area. I'm going to go ahead and switch my views up so I have a couple views to work with. And there's this functionality that allows me to say, just isolate the area that I'm working on, the things that I have. So I'm going to go and do that so I can look at just that duct information and see what's going on with that. Not quite sure why we went up, over, and down again. So what I'm going to do is delete that information that we don't need. And move it. And I'm going to move it from connector to connector. And if it didn't like what I'm doing, I would get an error saying, you know, we just can't build that. But it looks like we actually can. And what I'm going to do is now save my file, and then back over in Navisworks, if we're still working away, all we really need to do is reload that information. So just refresh our screen, reloads the stuff that we have, and then over in my clash detection, it comes back and tells me that, you know, you're not seeing all of the information you need to see, so what we want to do is update that information as well, and it's going to tell me that, okay, we have 63 active, one's reviewed, and one's actually solved. So when we go look at the solved, it's in yellow. So letting me know that that's been resolved, and you can see that automatically updated. And remember I talked about reporting, so now we have the ability to go in and create an Excel spreadsheet of the reports. And it's going to have what the clash is, what's the active, it's going to have the pretty picture with it, and then any of the other notes and stuff that we've assigned. So you can see that there's that one that says, let's take a look. Okay, and the next piece I want to show you is what we call the timeliner, and it's got a couple different things that we can do with this. Basically, it's the sequencing of how we're going to put this building together. And it's going to run through it real quickly here, and what's going to happen is the floor is going to come in all at one time. And this was kind of the limitation that we had in the 2011 and down versions. In the 2012 and up versions in Revit, we have the assemblies, what we also would call a part maker, that we can split that floor up. So as an architect, I don't really care. It's just it's a floor. I'm not going to worry about the pouring side of things. But on the structural side of things, they really do care about how things are going to get poured and a timeline of that as well. So what we can do now is we can actually create parts and split that information up. So what we're going to do here is we've already split it up, and we're going to add these tasks into our schedule. Now we can do this either in the schedule that you're familiar with, or we can do it directly inside of Navisworks. And here we're actually doing it inside of Navisworks. So we're going to set those times up. We put them per day. And then once we get done with that, we're going to go ahead and run the simulation and see how things are going to work. All right, so here it comes in the way it was coming in before. Then watch how the floors come in. So now that it was one floor, now it's coming in chunks of floors instead. Anything green means it's not finished yet. So it comes in, it pops in different areas of green means we're not quite finished with that. So think about how a wall goes up with inside a building. So we build a structure component of that, then we build the interior sides of things, or we build the exterior and then the interior, depending upon what piece of the pie we're building. It's saying that in this case it's not finished until it comes to a color other than green. And here's a quick look into the interior, so you can kind of see that the studs are going up. There we go. Okay, folks. So point clouds. What are point clouds? So, it's kind of relatively new to our area or industry. They do a lot of it over in the civil side of things, but basically what a point cloud is a scan of something. And we're scanning, in this case, we're actually scanning the PPI entryway here. So you can see that it's zoomed in. You can see a whole bunch of little tiny little points. So what technology is out there that creates these things? And when we do this, when we're looking at maybe I want to use this, we really want to get kind of the right technology for that. So there's a couple different things you can look at, different types of equipment. Obviously, we're not going to use this particular one called the Airborne LiDAR scanner. Basically, this is going to be for the corridors and large-scale mappings. Basically, a plane driving over. This is a shot going south from, that's the Burnside Bridge, if I remember correctly. And the accuracy is not really there. I mean, we're talking, 3 feet accuracy, but the whole idea is that we're just kind of quickly scanning information. Ones that you guys have probably seen in the past is what we call time of flight scanners. And a time of flight scanner basically is what you see guys out on the road scanning that information. And the accuracy is very, 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 very accurate. And for our side of things, it's really more for long range outside of the building side of things. And it's very durable and get wet, that type of stuff. And then there's the inside of the building, which we call time-based scanning. And time-based scanning basically is for excuse me, the same accuracy as the other one, but it's made for interior side of things where we're looking at very fine accurate, like the ductwork that we're seeing there. So that's kind of the idea behind what the scanner technology is. Let me go show you a quick scan of that. In fact, I'm just going to do this one live. Live seems to be a lot faster. So what we're going to do is we're going to bring in a point cloud. So we go over to the Insert tab here, and under the Insert tab we have Point Cloud. And when I pick it, it's going to allow me to bring in the different types of point clouds. And down at the bottom here is the different ones that we can bring in. When I pick that one and I grab this entryway here, what's going to happen is Revit's going to give me a little error message saying that, it really needs to be a PCG file. And a PCG file is a unique way of Revit managing that particular point cloud. So I'm going to go and cancel that, and I'm going to bring in that PGC file. There we go. Now it's actually in. It was that quick. Now you don't see it because I just went center to center, and there it is up on the side there. So I zoom up a little closer to it. What I can do is a couple little things to it. I can grab it. I can move it. So I can grab this one. I can move it down. It's actually to the ground here. We can control it with what we call visibility graphics. So we have under the import category, we have the ability to turn them on and turn off visibility wise. We also can go over here to the Manage Links tab. And under Manage Links, we have a whole little section called Point Clouds. And we can manage it based upon reloading from, unloading, and just removing that point cloud. So once we have a point cloud, and what is it that we can do with it? Well, we can draw on top of it. So there's a couple things we can do. I'll get a little closer. And as I get closer, you can see that the more points are happening to it. So I'll go out a little closer. And the farther away you are, the more things you can snap to. So I'm going to go ahead and say I want to draw a wall. That wall is going to be unconnected at, let's say here, 20 feet high is fine. And I'm going to go and use interior face of the wall. And as I move my mouse around, you should see some little X's happening. And that X basically says that it found that particular edge, a coplanar edge that I can snap to. So I'm going to go and grab that one, and I'll flip that over. You notice it finds the intersection of that point, and it's also going to find perpendicular to that one. So once I have, let's say, something drawn here, I could also go off here to my section tool and create a building section. Go look at that section here real quick. You can see there's the point cloud. I zoom a little closer here. You can see our little PPI bikes that we can use for going to lunch and all that good stuff. The whole idea behind the point cloud is to be able to visualize and see what's going on. This is what it looks like today. So I'm going to go ahead and set this up so I can view it in a section view that I just created. Pop into that. There we go. And let's just rotate this around so you can see a little bit more there. Okay, so this little circle, we just did a quick scan of our building with our scanner guys downstairs, and that's where the scanner was. And what you're seeing right here is a window. And so all of this little stuff that we're seeing over on the side here, that is all the what we call our gift shop information. So I really don't care to see that. Now in the scanner tech stuff that you have, you can actually remove that information. But that's this for demonstration purposes, that we can actually use our crop and just crop that information out that we don't want to see. So again, the whole idea behind bringing scans in is to be able to see what the current conditions are and trace on top of that. Now, that point cloud that I just brought in was close to 2 gig file. And you see how quick, even with the video problems that we're having, see how quick it was for me to rotate that information? So what Autodesk is doing by that PCG file is actually condensing that file down almost in half or over in half, but still that's a 661 kilobyte file, basically 660 gigs. Not gigs, but megabytes. Think about how big that file is, rotating that around in just Revit. But see how quick it was just rotating that file around. So the whole idea is that when we convert it, we want to use the internal process of Revit to convert that. It basically took 30 minutes to convert inside of Revit. All right, well that's my stick for the day. I'm going to try to open everybody up for Q&A. Let's see here. Host, control tone, record tone. There we go. Can somebody say something? Thanks, Teo. Do you guys have any questions? A couple things before we open it all the way up is that there's the up and coming events. If you fill out your survey form, you get this chance to win this lovely 3D connection mouse. That's what I was using to zoom around in the videos today. It's got a lot of functionality to it. In Revit, we didn't really have the ability to do that, to use this one. The ball or the wheel itself, that's basically just rotating in 3D. But all these little buttons that you see around it do a lot of stuff in 2D and the 3D views of Revit. Plus you have this little functionality in the middle here that actually does a lot of things, like in my case it's looking at emails and things of that nature. So with that, I'm going to go ahead and open it up. If you have any questions that I can't answer or I need to get back to you, just put that in your survey form as well. So open up for questions. Oh, it's very tiny. Yeah, I don't have an actual number, but it's just a link, so it's not actually here. Yeah, yeah. So it's just a linked file. So and we had the color turned on too, so you can see that there was color and texture and things of that nature. Now it's the baby version, and I say that because it's the first flavor, first time it came out. But they did a really nice job of just be able to manage point clouds with inside of Revit. So the whole idea right now that you can trace certain things on it, but the idea behind it now is that you want to see what is existing, and kind of go from there. Now we could also do what we call stitching. So we could have brought the whole entryway and the whole thing in as one big group and brought that in. I kind of like the ability to have them in separate ones so they're not one big file, and we can turn them on and turn them off as we go. Other questions? Thanks. Oh, sure. So when you do site component, kind of give me a better feel for that. Mm-hmm. Okay. I would say it's going to be a combination of more than likely Civil 3D, because Civil 3D is actually doing the grading and the actual design of that. But when it comes to the structural components, that's something that Revit will do for the timbers and things of that nature. Yeah, Revit Architect. Well, you're not worried about the analysis, structural analysis. Yeah. Yeah, the biggest piece is between Revit Structure and Revit Architecture is all the functionality that I showed you today is in Revit Architecture. What isn't there is that analysis piece of it, so we can't add loads, we can't send it over to our analysis product and modify it there and bring it back. There's not round tripping. We don't have that, what we call the analytical piece of it in Revit Architecture. That's what Revit Structure it has, and they have like the rebarb and some other things that we don't have, we don't really necessarily care about. Yeah. Yeah. So all of the stuff that was there. The only thing that wasn't, that you cannot create as what we call parametrically, would be the rebarb that you've seen on that one piece. That's something Revit Structure has. And to be honest with you, they only do it for onesie twosie, like that assembly. We're going to build one assembly and say we need 10 of these. So they're not going to model the rebarb. Mm-hmm. Any other questions? All right, folks, we're going to wrap it up then. Thanks for showing up. And again, I'm going to record this because it was running really slow. I'm going to test out the recording to make sure that it was okay. If not, then I'm going to rerun the recording so it's a lot faster, not as jumpy, and then we'll post it up on our web. So keep that in mind, and thanks very much. We'll talk to you later. Thanks. I think it's going to PPI website, but you might get a link as well. You bet. Thanks, Dale.